Welcome to the video. In this lesson, we're looking at 6.1, where we're going to find properties of exponents. Exponents are, for the most part, is a value. It's a value that is, well, here's an example. So, for instance, I have 2 to the third power. All right, this is an example of something that is written in exponent form. The 2, which it could be a number or it could be a variable, this is going to be called the base, all right, of our exponent form. All right, the exponent itself is the number that's on the top right of either that base. And so what this means is whatever the base is, you are going to be multiplying that value to this many times. So 2 to the third power is the same thing as 2 times 2 times 2, which if you evaluate 2 to the third power, you would get an answer of 8. Now, there are several different types of rules that we have to take a look at in order for us to simplify exponents the best we can. For starters, we have what is called a zero exponent. And by rule, what it's stating is that if you have any base that is a non-zero number, so as long as your base is not 0, if you raise that base to the 0 power, it is always going to be equal to 1. So the example they gave here, 4 to the 0 power is equal to 1. 8 to the 0 power is equal to 1. Negative 5 to the 0 power is going to be equal to 1. So that is what it means to have a 0 exponent. If you have a negative exponent, all right, the goal that you want to do is we are trying to always make our exponents positive. So when you look at this particular one where we have 4 to the negative 2 power, it is actually the reciprocal to the non-negative exponent. So 4 to the negative 2 power is the same thing as writing as 1 divided by 4 to the positive 2 power. And they were talking about reciprocal, which makes sense. So if I say, oh, what's 4 squared? Well, 4 squared is 16. Well, what's the reciprocal of that? Well, that's 1/16. That's why they're saying that this is the reciprocal of the original base to the positive power. So this is the kind of the rule here. So anytime you have a negative exponent, it is always going to be positive in the denominator. Same thing goes for if it's in the denominator, it would be positive in the numerator. So if you had something like x over 3 to the negative third power, this is something you could say, oh, this is going to be 3 to the third power times it by x. This would mean the same thing because it was negative in the denominator. That means it will be positive in the numerator. If it's negative in the numerator, it will be positive in the denominator. Hopefully that makes sense. So in this particular situation, they are asking us to evaluate each expression. For part A, it's 6.7 raised to the 0 power. Well, as long as 6.7 is not 0, which it's not, it's going to be equal to 1. For part B, what I would advise you to do is instead of calculating it as a negative exponent, let's create it as a positive exponent. So If this is negative in the numerator, it is going to be positive in the denominator. And 1 over, it's negative 2 times negative 2 times negative 2 times negative 2 is going to be a positive 16. Here they want us to simplify the expression. It says write your answer using only positive exponents. All right, so first off, I have this x to the 0 power. As long as x is not 0, I can say something like as long as x is not 0, I'm going to say that that is 1. So I got 4 times it by 1. And now I have this y to the negative third. If it's negative in the denominator, it's going to be positive in the numerator. So it's going to be y to the positive third. So to simplify this, it's going to be 4y to the third. There's 3 other rules that we're going to look at. The first one there is called the product of powers property. Product of powers property means this, is if you have the same base. So in this particular one, they both have a base of 4. And you're multiplying same base values. What you get to do is when you multiply them, you are simply adding the exponent. So I have 4 to the 6th power times it by 4 to the 3rd power is going to be equal to 4 to the 6th plus 3, which is 4 to the 9th. So again, this is going to become this when you put them together because you are just adding the exponents. So this is the general rule is, so if you have a to the m power times by a to the n power, it's going to be equal to the sum of the two. Next, looking at quotient of powers property, which means is if you are dividing same base values, you are going to subtract the exponent. So I have that same 4 to the 6th power divided by 4 to the 3rd power. The bases are the same. They're both 4. You simply subtract them. 6 minus 3 is 3. So this turns into this. So the rule is if you have a to the m divided by a to the n, it's going to be equal to a to the m minus n power. Finally, this power of a power property, which means is if you have a value or a base and an exponent in a parenthesis, and then it's raised to another power. So how it is said here is 4 to the 6th power, then that is raised to the 3rd power. So you have like it's almost like it's like double exponent there, and because of that double exponent, you multiply those exponents together, where 4 to the 6th power to the 3rd power turns into 4 to the 18th power. So the rule is if you have a to the m power, and then it gets raised to the n power on the outside of the parentheses, it is the product of it is a to the product of m times n. So here they're asking us to simplify each expression, write your solution using only positive exponents, all right? So they say simplify. They're not asking us to evaluate. So evaluate would mean like if at the end of it, it said 3 squared, give it to 9. I think they just want us to leave it in exponential form, but they also just want to keep it positive. So we're going to take some of the rules that we looked at earlier on in the section. So looking at example A, I have 3 to the 2nd power times 3 to the 6th. This is going to be 3 to the 2 plus 6 because you add the exponents together. So it's going to be 3 to the 8th power. Looking at B, because I have same base values in its subtraction, I got negative 4, and it's going to be 2 minus 7. So this is now negative 4 to the negative fifth power. But because they want it to be positive exponents, what was negative in the numerator is now going to be positive in the denominator. Looking at example C, I have z to the fourth, then it's raised to the negative third, so this is using the power of a power property, where I have z to the 4 times negative 3, so this is z to the negative 12th. I need it to be a positive exponent, so if it was negative in the numerator, it will be positive in the denominator. All right, and then the final property looks quite similar to power of a power, but this is, it says power of a product property. And what this entails is if you have several different bases inside a parenthesis and they get raised to a certain power, you're almost like distributing that exponent to every term that you're multiplying by. So since this is all products, this fifth power gets attached to both the 3 and to the 2. So it gets 3 to the fifth power times it by 2 to the fifth power. That also works in quotient. So I have 3 halves here in parentheses, and it's also raised to the fifth power. So this fifth power gets attached to both the 3 and both the 2. So that's where I get this uh, evaluated, or this simplified expression there. So looking at it with these types of examples, I have negative 1.5 times it by y, and then the whole thing is raised to the second power. So this 2 gets attached to both the negative 1.5 squared and y also gets squared because it goes here and it goes here. Actually, technically, it should go, it should be, actually, this is like saying negative 1. Well, actually, let's, even though it says simplify, let's evaluate it. So negative 1.5 squared is going to be what? Positive 2.25 y squared. All right. Let's evaluate it. Here, the third power is going to be raised to both a, so I got a to the third, and then this is going to be negative 10 to the third power as well. So what will happen is this will stay as a to the third, and if I evaluate, this will be negative 1,000. For C, this 4 is going to be attached to 3 to the fourth. It's going to be attached to D to the fourth, and it's going to be 2 to the fourth. So it went from here to here to here. So when we take care of all of the exponents, let's say numerical wise, so 3 to the fourth is 81. I got D to the fourth divided by what, 16? 81 divided by 16 gets reduced to, I think that's in lowest terms. And then finally for part D, I got 2 to the negative 5, I got x to the negative 5, and I got 3 to the negative 5. Now here what I would do is make everything positive. So everything that's in the numerator will be in the denominator, and everything that's in the denominator is going to be in the numerator. So this is going to be changed to 3 to the positive 5 divided by 2 to the positive 5, x to the positive 5. So looking at this, 3 to the fifth power is 243. 2 to the fifth power is 32, and this is x to the fifth. And I believe that is in lowest terms. And that is being able to look at properties of exponents. Hope this helps. Till next time.